Okay, this is continuing on in chapter 8. Um, this is the next part is talking about string conversion functions. Last time we were talking about the different functions to tell if something's uppercase, lowercase, punctuation, is digit, I think is one we looked at. Now the string conversion functions, these functions convert strings of digits to integer and floating point values. And here we got these string conversion here. So, and as you read these, this tells you what do you need to pass in. So when you see a double here, that means it's going to return a double. You see long here, that's going to return long, unsigned long, that's going to return unsigned long. These are what's passed in as parameters. So you need to get used to reading these different definitions. Okay. String to decimal converts a sequence of characters representing a floating point to double. I guess D for double, not decimal. Function returns 0 if it's unable to convert any function. Function receives two arguments, a string and a pointer to a string. And like this is 8.6. So let me open that up. Okay, file open. It's not too much to the program. Up here we got a string defined, and then the pointer. Now if I let's run it first and see what it looks like. So this, the string 51.2 are omitted is converted to the double value 51.20, and the string percent are omitted. Okay. So notice here this string pointer is the one we're working with down here. And we're doing our conversion. We're passing in the string and then the pointer here. Now the string and then the %s is converted to the, so, and then it's passing in string. Now that should be at that point 51.2% are omitted. It's a full string. That's what we're passing in there. And converted to then the double value %.2f and the string, then %s. And then here I got D. Now what's printed with the D is just the 51.20. It does not put the % are omitted. That comes off of the string pointer. What they're indicating with this example is that you could have a mixture of alphanumeric characters and numbers, And when it does this string to decimal here, it doesn't blow up like some programming languages might. It does what it can. So basically, it took 51.2 and assigned it to the variable d. Now, if I change this, put happy in front of it, and see what happens. Notice it does not find the 51.2. It says double value is 0.00. It's because it runs across these first ones that are not digits, not numbers, and that stops it right there. It says, okay, well, we're done. You're trying to convert something to a double that's alphanumeric, which basically means your number's got to be at the very beginning in order for that to work. Does that make sense on what that's doing? No, why would you need to do this conversion? Well, example of it is if you're asking the user for input, and let me show it. Okay, double D1 and scanf. Let's see if I can remember this percent. I think LF, not F, and ampersand D1. Printf, the number was %F slash F/n and D1. Okay, so it's coming up here, and if I put in 3.1, prints 3.1, nothing too exciting. But then if I put 3.1 and put my name in there, boy, that's it. I thought that would bomb off. Interesting. How about if I put David first, 3.1? Still works. I fully expected that to not work. But if you're reading something in that's a string, that's a number, it allows you to do error checking before you do the conversion. So that's the idea behind it. Although it appears to work either way, even if you don't do the error checking. You know, examples of this is I could, as I read this in, I could check to see if something's a digit or not. I go through it character by character, and if they put something that's not a number or is numeric, then I could alert them. This converts it from a string to a long integer. Kind of the same principles as the last example. Here we got a string, and notice the asterisk there. That indicates our string pointer. And then I got negative 1, 2, 3, 4, 5, 6, 7, A, B, C. And down here, got a character pointer. And then our variable X. And here's where I'm converting the string to our long integer. And you can probably guess what's going to happen. Original string is this. The converted value is negative 1, 2, 3, 4, 5, 6, 7. That's the X after we're doing the conversion. So again, it ignores the ABC on at the end and assigns it to the long integer. Which then kind of negates the idea of why do you do it? if you can do it anyway, and it goes ahead and converts it. But Um, okay, the remainder of the original string is remainder pointer. So our pointer is going to point to ABC. So start of that. So it goes through, and that remainder pointer that you see on here points to where there's an issue. I suspect it would, if there was no issue at all, it'd either be null or point to the end of it. Let's see. I'm just curious. 8.7. Okay, so if I run this, and actually put in a, guess it's hard coded. Okay. Okay, so remainder of the original string is, and then it says blank, because I put in all this is a valid number. So, remainder pointer is a character pointer. I guess it doesn't matter if it's null or not. Because I don't think it'd be at the end of the string. But anyway, that's what that parameter is for, is to point out if there's any issues. And where did it stop collecting the string, the integer that contained in that string? What's it? Unsigned? Yeah, unsigned long integer. So again, it's string str to to, and then u for the unsigned long integer. And we're again passing in a string of characters, or array of characters you can think of, a string. And this will be the pointer to where it stops, assuming it's invalid number that's input. And what's a 0? Third argument indicates value to be converted can be an octodecimal or hexadecimal form. Hmm. String to UL. String to UL, C programming. The last option, the integer base, says must be between 2 and 36 inclusive, or be a special base 0. So that kind of implies that with PowerPoint's incorrect, exactly, or incomplete maybe. They say a third argument 0 indicates the value to be converted can be an octodecimal or hexadecimal form. Well, octal's base 8, so it means we put 8 in for octal. decimal I'll come back to. Hexadecimal is base 16. So we put 16 in for that. But this implies that you can put any base in. Base 2, base 3, base 2 is binary, base 3, base 4, base 5, so forth. Now it says a special value 0. I'm thinking 0 is decimal. Doesn't really indicate that over here. But the fact that they're passing in 0 must indicate it. Let's see if there's anything else. Okay, the base is 0, the number is assumed to be decimal. Unless the converted number starts with O for octal. O or 0x for hex. Okay, 0 maybe a row. Okay, so 0 does mean decimal. I don't know. Let's just try to do hex and see. Because hex, ABC, is actually valid. See, this is 8.8. The instructions I was reading there implies that you didn't need to do that on that other page. Okay, what in the world? That's 8.8. Okay, so we'll change this. When it does the conversion, we'll put base 16 here, in which case that entire number should be fine. But we're converting it to a long integer. If I put a in here. Okay. Yeah, a and hex is 10, so it does work. You don't have to put the 0 hex like that one website indicated. In binary, that's 2 to the 0, 2 to the first, 2 squared. So that's 4 plus 2 to the 0 is 1. That should give us 5. It does. Does that make sense how to work with the different formats? Just a brief overview of that. I put in 1, 0, 1, like that. This first one here is always this is 2 to the 0 power. This next one is 2 to the first power. This first one is 2 squared. What that means is you take the number on top and multiply it times this. So the 2 squared is 4, so that'd be 1 times 4, plus, then you take the number up on top, which is 0, times 2 to the first. 2 to the first is 2, so I got 0 times 2, plus 1 times 2 to the 0, and anything to the 0 power is 1. 1 times 4 is 4, 1 times 1 is 1, so it gives me 5. in decimal. Uh, right. Yeah, I like to think of it as ascending from the right hand side, because this first one's always 2 to the 0. And then as you have other bases, like if I had base 6, for example, you can only use the digits 0 to 5. Like if I had this base 6, then clear over here would be my 6 to the 0 power. My next one here is 6 to the first power. And that's 6 squared. So this would equal 1 times 6 squared, which is 36, plus 5 times 6 to the first, which is 6, plus 3 times 6 to 0, anything to 0 power is 1. Gives us 36 plus 30 plus 3, 69. So 153 in base 6 should give us, in theory, 69. So I did all my basic math correct. It does. Gives us 69. So pretty flexible. Does that make sense? Yeah. Yeah, they're all the same. Doesn't matter what your base is. In fact, it goes up to I don't know what this other would mean, to be honest. Hmm, interesting. You got hex, which is base 16. And it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 is A. B is 11. C is 12. D is 13. And E is 14. And F is 15. Now, the base always goes up to 1 less. So it goes from 0 to 15. But I don't know if you start talking about different bases. If I change that to 17, which is not hex, if it discontinues the alphabet, probably does, which would imply I have a G of 16. So let's try to change G and just see if that's a correct assumption. So this would be my number, G. And I want to change that to base 17. And that should return 16 if it works like I think it should. 16, sure enough. Okay, I never have worked with any base higher than 16, so that's what I was curious. Goes up to 36, so you got 20 more. That's got some issues, doesn't it? How many letters are there in the alphabet? 26, which means I got 10 more places, and then all of a sudden, what do you start putting for the digit? Because it's got to be a single digit. Just because I'm curious. I don't know. Just it doesn't matter. We're not going to work with base 36. Okay. 8.5, standard input-output library functions. This section presents several functions from the standard input-output library, specifically for manipulating character and string data. And this inputs the next character from the standard input and returns it as an integer. Again, the int is what's returned. The void is nothing. Nothing's passed in. Then we got f get s, put char, put character, put s, the string. sprintf, scanf. Really want to get down to the code example. 8.10. Okay, so here we're defining a character array. The size is hard-coded up here is 80. Remember how these defines work. When it compiles, it'll go ahead and replace this size right here with 80 everywhere it sees it. Then I got to put s, says enter a line of text, so put string. And to get that to come in, you use this. So f get s, and then we're passing in sentence. This is our character array. And then the size of it, and then standard in. And it then prints it backwards. Printf original string %s/in, and the %s is what you use for the string. That's why I put the %s there. And then this would be our sentence. If I'm using the right format specifier. We'll see. You might have to do it a character at a time. There it is. Okay, and then this reverses it. So a different way you can work with it. This might be a little bit more similar to what you've used in other programming languages, if you've used other programming languages. Instead of working it character by character, you can use it in this form. So put s just writes out a string, and then f get s. We have those parameters. Now David was here. Notice that it has the entire string as David was here. Normally, when you're talking about having spaces in there between your input, it assumes they're in different variables. But using the fgetS, that brings it all in. You can use spaces, you can use whatever you want. Probably can't use control sequences if I had to guess. Now let's talk about this reverse, what it's doing. Remember your array of characters. When I typed in, David was here. That's position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But here at the end, it's got this /0 right here. So you don't have to worry about putting it there. It's put on there automatically for you. Now that is not two characters, even though it appears like two characters. That's just a single character in terms of programming. So, that's weird. I would have probably put my pointer here for 0, like that. But it doesn't matter the order. So if it runs across the end of the string, then we're done. And it does this return. Otherwise, what it does is it recursively calls itself over and over. Because it doesn't know how many characters it'll be. It could be 10, could be 5, could be up to 80. I'm not sure if it can be 80. You have it defined up above as 80 for the size, but I'm not sure if that /0 has to have a spot for itself. If so, then I can put 79 in there. Then once it calls itself, it's passing in the pointer. Oh, okay, I see. I was wondering why it's passing in 1. But when it does that, what it does is it moves it to the next slot. Remember how we added a number to the location last time and moved to the next memory slot? Well, same principle holds true here. And then this prints it. Okay, 0 must be the offset on that case, not the index. Because otherwise it'd print position 0 over and over, which would be our first character. Strings are tricky. That's why I'm going through these examples and so forth. Okay, get character. Grab a drink here. We'll take a look at figure 8.11 here in a minute, but uses functions get character and put s to read characters from standard input into character array sentence and display the characters as a string. Okay, so we got our put s, we write out a string. Now get character, they got it embedded into a while statement, and that is the appropriate place. Although there is another way to do that. But this will go through and read it character by character until the end of the string. And it's building the sentence, which is our character array up here, character by character as it's being input. Okay, so let's take a look at that. 8.11. Okay, so if I run this, tells me line entered was David was here. Again, notice that it ignores the spaces. Wasn't until I pressed the enter that it said, okay, I'm done with this, done with the array of characters. I said it could probably be done differently, so let me think this through. If I had another character sentence 2 size, and I want to set I back to 1, initializing the counter, and I'm gonna say C is equal to get character. Typically, it's written in the while statement like you just saw. And while I is less than size minus 1, and C is not equal to our slash n, then sentence 2, I plus plus is equal to C. And now I do another scanf, or get character, I should say. C is equal to get star. Let's see how that works. Unlike something, semicolon, put this, the line entered was oh, there's David was here. I like this splitting it up. Usually you don't split it up. Usually it's all within that. Why didn't I like it though? Okay, David. Next sentence. C equals get character. I don't know. Let's have some leftover from up here. Of course, I'm just getting character at a time here. Yeah, let's try that. Oh, it's because I pressed enter. Okay, that makes sense. Because if I press enter here, that indicates into that. And then if I'm pressing, typing here and pressing enter. Now it does have some other issues. Get some weird characters. That means I'm going beyond where I should. Um, hmm, put that in there. Hmm. Oh, I didn't terminate the string. See, here they got sentence. I didn't see that. Since I'm reading this character by character, I have to put the /0 on there. Otherwise, it keeps going beyond the end. Okay. Sentence 2, I equals /0. And this I want to move. It's right here. David. Okay. Like I said, there's different ways you do it. The standard way in every programming language is you put it in the while statement directly. And I always think it seems strange for students because they're sitting there, well, how do you read that? I know this is true or false. Well, what this does is it does this first. Goes out and gets a character from the user and assigns it to C. And then takes that and compares it to the /n and returns true or false. Like I say, it's kind of weird. It's kind of like having a statement right here, an assignment, and then you're taking the results of the assignment and you're comparing it to a character. Is there any questions on the get character? Okay. sprintf, print formatted data into an array. S, an array of characters. Now notice here, we got S, which is a character array. And then down here, sprintf, we got S, and then we got integer colon percent 60 /n double percent 8.2f, and then we got x and y. X is an integer, y is a double. So instead of printing it to the screen, I don't think that prints to the screen. No, sprintf doesn't. It prints it to an array, specifically an array of characters. Now, if I were to print out the formatted output stored in array S is integer double. And notice that they're on separate lines. That's what the /n does at line 7, end of line 17. Other programming languages, you might have been used to handling that differently. One of them is where you can concatenate them together. So you concatenate them together, and then you can you have your results. Well, this is different. We do a concatenation, but it's embedded within one format specifier here. Then you're passing in the variables. scanf to read formatted data. See here, we got our scanf, and we got S, and then %D, and then %LF, and then ampersand X and ampersand Y. And I try to remember if it allows you to put something besides a space. In this example, see how they got 31,298 space 87.375. The space is what separates those and what causes them to go into different variables. Let's see, string manipulation functions of the string handling library 8.6. Got string copy string 2 into array S1, the value of S1 is returned. String in copies most in characters of string S2 into array S1. Character string cat. This appends string S2 to array S1. If you've heard of concatenation, so concatenates them, puts them together. And string in cat appends the most in characters of string S2 to array S1. If you tell it 10 for the length, the number of characters, there isn't 10 characters, then that's what they mean by that. Appends at most in characters. And where's the code? String copy, string in copy. Okay. It's 8.15. Okay, so I got an array of characters here. Happy birthday to you. And creating two other character arrays based on size 1 and size 2, so 25 and 15. And then printf, the string in array y is string copy yx. Okay, that's what I would expect. When you do the string copy here, the y is 25. And happy birthday to you doesn't have 25 characters. So it should print everything. And you see, first one prints everything. Second one prints everything. The last one doesn't. String in copy z comma x, and size 2 minus 1. Copies the first 14 characters. How come you think first 14 characters? How come we don't copy 15? Because when you're using the in, you have to manually put your /0 on at the end. That terminates your string. So since there's 15, the size is 15, you got 14 to work with, and then you got that last one for the /0. Okay, the code for this. 8.16. Okay, so got here 20 and then whatever, and then 40. So the 20 is our size, the 40 is our size, the whatever, the blank here, is based upon wherever they input. Printf S1. Okay, just print S1 and S2. Nothing exciting there, just plugging them straight in. Now concatenate S2 to S1. So we got happy space and then new year. So after this string concatenation gets done running here, it should say Happy New Year. Next one is take S1, concatenate that to S3, which is a space or it's blank, empty. Okay. I think S3 would contain Happy New Year when that's done. Yeah, it does. No, it says Happy New Year. Okay. What am I seeing around here? S3 was, oh, yeah, because S1 is happy. So S3 already had Happy New Year, so we concatenated on happy, and that's why we have Happy New Year. And this one is based upon just six characters. Now it was 6 characters, and notice we got happy space here. And that's off of S1. S1 is the one we built. So it was Happy New Year, if I'm looking at the right one. Anyway, that's concatenation. You can compare strings, string compare. Notice it returns an integer, so returns 0, less than 0, greater than 0 if S1 is equal to, less than, or greater than. We got string in compare, where you compare so many characters. String compare S1 to S2. Happy New Year. They look equal to me. Oh yeah, 0 means they're equal. Now it's comparing on line 15, comparing S1 to S3. S1, S3, happy holidays. So, see, the question becomes: is happy holidays versus happy New Year? Is the H greater than or less than the new year? I looked at the ASCII table last time. This is where you can look at the ASCII table to see what that would return. And what are we comparing? H and holiday to N and New Year. So H and N. H is right here. Decimal, that'd be 72. N down here would be 78. Okay. So then that gives us a positive 6. 0, 1, 2, 4, 5, 6. Okay, so it oh no, I'm looking wrong one. Up here, 1 and -1. Okay. So again, it just tells you the order, and it's based upon the first letters are the same: happy, happy, space, space. What's different on them is the next one, which is holidays and new year, of course. And then you can compare just certain characters here. Searching. String character locates the first occurrence of character C in strings. Size underscore T string CSPN. Determines and returns the length of the initial segment of string S1. Consisting characters not contained in string S2. String SPN determines and returns the length of the initial segment of the string S1 consisting only of characters contained in string S2. And string P break locates the first occurrence in string S1 of any character in string S2. So again, just different ones. String R character locates first occurrence of C in string S. If C is found, a pointer C in string S is returned. And then string locates first occurrence in string S1 of string S2. This is probably the most useful. String is found, a pointer to the string in S1 is returned. Otherwise, a null pointer is returned. So you compare it by doing an if statement and if it's equal to null. And then string token, break string S1 into tokens. I'm not going to go over all these. Just don't have time. 8.25. This is an interesting one. They've tried to include everything under the sun, but there's some that are more important than others. Okay. So here it's looking for one string inside of another. It's looking for DEF inside of A, B, C, D, E, F all the way up. So we're looking for DEF. There's two DEFs. Notice that. One right there, and there's one right here. Well, let's see how it handles it. Okay, oops. Try running that again. Okay, well, this first one just prints the value of string 1 and then the value of string 2, which is just what we got defined up here. When it does this string search, it looks for DEF. It says the remainder of string 1 beginning with the first occurrence of string 2 is DEF, ABC, DEF. So it's going to return a pointer to this first D right there. And then from there, print out the result. This is an interesting one. This is kind of a useful one too. So let's take a look at it. This is a sentence with 7 tokens. When we say tokens, specifically, it's separated by spaces. So if I ran this, see how it accesses each one of them separately. If I was reading it from a file or from the user input, something that was CSV, commas between them. It's like this. I believe we can put a comma here. Put a comma there. And see how it separates those into 1000, happy, and 23.2. You could write your own algorithm to separate those based upon where the commas are. And I've had some of you do that in other languages. You've been in C# or something, and I'll bring in some CSV format, and I'll tell you to separate that. And that's mainly to get you to think about how a string works. But most programming languages have some kind of tokenizing function that allows you to split them up in that manner. So it makes it a lot easier. Now at this point, once you separate these into separate pieces, you can assign them to other variables, do the appropriate conversions, and so forth. Does that make sense how to separate a CSV, comma separated value file? At least for the record. Okay. Memory functions, not going to really get into that. It's kind of interesting if you want to read it. More memory. String length is kind of a nice one. String error, I really don't use hardly at all. But string error maps error number into full text string in a compiler and locale specific manner. Pointer to the strings returned. And the length determines the length of string S. Number of characters preceding the terminating null character is returned. You know, if you're trying to loop through and you don't know what the length is, and you can use that to get the length. Okay, so it tells you that the letters A through Z has a length of 26. For length 2, our second length, we got 4. Then Boston, 1, 2, 3, 4, 5, 6. We got 6. And then secure C programming. I can go over that. I'll let you read that. Questions on any of those functions? Well, I'll put a project out there from the textbook and upload this video course, and we'll go ahead and call it quits there.